Have you ever watched a magician perform a magic trick? I don't know about you, but they always leave me wondering, like, how did they do that? So I've worked alongside some, I guess you can call them weld magicians, and I was always amazed how they can control that distortion on any project they work on. When you understand weld distortion, it changes the game on how you go about fabricating the project and the outcome of the project. So what I want to do today is pull back the curtain on welding distortion and give you guys some techniques so you can avoid distortion and help keep your project straight, square, and level. So with that being said, let's get right into it. All right, so I'm not sure if you remember my previous video, but I went over how the weld pulls your metal towards the weld. Now this is a key concept to understand for my first point here, which is weld leverage. Now, depending on what joint you're working with, whether it be like a butt joint, lap joint, T-joint, outside corner, each joint is gonna have a different, I'll call it weld leverage level. So for example, a T-joint or fillet weld is going to have way more leverage and distort your part way more than like an outside corner joint will. Just because of the nature of the joint and how it's positioned, the weld only has a certain amount of leverage for each joint scenario.
The best way that I could think of to explain weld leverage is, let's think of it like the leverage you have with your hand. So like the further you have your hand open, the less leverage or grip you have to hold something. But as you close your grip and your fingers get closer to each other, you have way more grip and leverage to hold something. So think of the two pieces of metal that you're welding together just like your hand. So the further apart the two pieces are, like in butt joints, the less leverage it has. And then the closer the two pieces of metal are, like in fillet joints, the more leverage it has, just like your hand.
Also, another huge factor is the direction of your weld. Now, Jody from Welding Tips and Tricks did a whole video about this a while ago. Mad respect for the guy. He has been doing this for years and knows his stuff. So I've actually experienced this personally. So when you're welding along a joint, not only does the part want to pull towards your weld, but it also pulls in the direction that you're welding. So if you're welding a long joint, at the end of the joint where you stop, that's where it's going to pull the most. So understanding that your part always pulls towards your weld, and in some cases it pulls even more in the direction that you're welding, that all plays a huge role when you're planning out like your weld placement on your project and a direction that you're gonna be welding each one of your welds. It goes a long way with avoiding distortion on your project. Which that kind of leads me into my next point, which is weld placement. So with weld placement, your biggest goal is to lock down your project as much as you can before you weld those joints that are gonna pull your project the most. So joints like outside corners and butt joints, lap joints, those are the ones that don't pull as much, so those are the welds you weld first, and you always weld your fillet joints last, because those are the ones that are gonna pull your project the most. So this is when you hear the term jump around. So yes, it's very important to jump around and spread out your heat along your project, but knowing everything that we know now, if you jump around to the wrong spot, and let's say you just jump around to all your fillet joints first, you're gonna pull that project like crazy. And then you're gonna be wondering, well, I jumped around and I spread out my heat, but if you jump around to the wrong joint, that's gonna pull your project and warp it. And when you're welding each joint, the direction in which you travel really matters too, because you wanna be traveling away from the section of your project that's gonna be pulling the most. Now, last thing I want to go over is machine setup and technique. Now, when it comes to welding technique and welding your part out, so it's kind of reverse on what you think. So like the hotter and faster you run, the cooler your part actually stays.
So for example, let's compare the stacking dimes technique to the dragging technique. As you can see here with the dragging technique, you're running a lot hotter and there's no manipulation and you're just throwing that weld in there and getting in and out. Whereas when you're stacking dimes, you have to run colder to get that separation in your dimes. And you have to go forward and then come back and then go forward and then come back. So overall, you're just going at a lot slower pace when you're welding. So you're spending more time putting heat into that metal since you're going slower, therefore increasing the overall heat input into that joint.
So machine setup and technique play a huge role too in deciding how you weld your project out. This is the secret sauce to welding your project out correctly. So let me put all these techniques that I went over into a scenario for you guys. You can see how this works in real time.
So I'll be welding these two pieces of square tube together on a square 90. As I'm fitting this up, I'm making sure to tack this up over 90 as a pre-welding technique. You can see here that I tack the outside first. By doing this, you give yourself room to play around with the fitment before you fully tack this up. So I made sure to have these over 90 around a heavy 16th because I know my inside tacks will pull this in a little to give me that 16th gap that I'm going for. And as you can see, once I have this all tacked up, it's at roughly a 16th gap. So like I said earlier in the video, weld the joints that pull the least first. So I always weld the outside corner first, and then the two butt joints next. And as you can see with the butt joints here, the direction that I'm welding, I'm starting on the inside and traveling to the outside to draw my heat away from the inside joint where it's going to pull the most. And then lastly, once everything is locked down as much as it can, I'll weld the fillet joint on the inside where it pulls the most. And as you can see, once everything is welded out, it's pulled to square.
Alrighty, so with distortion here, you can see this is a very intentional thing that you have to be constantly thinking about throughout your entire project that you're working on. But in some cases, there are times where you think you did everything right and you get done your last weld on your project and you look back and you're like, ugh, yikes, this thing is way out of level or square, like, now what? So there are actually techniques that you can use after you get done welding your project out to bring your project back to square, level, whatever you're going for. So there are techniques like flame straightening and actually using like welding techniques to bring your parts back. And I'll be going over all those techniques in the next video, so make sure to stick around. So as always, if you have any questions on any part of this video, or if there's anything you want me to go in more detail about, just drop those in the comments below. And with that being said, hope you liked the video and we'll see you in the next one.